Okay, great. Thank you guys all for joining me today. My name is Perry Krug. I am a principal architect at Couchbase. Been at Couchbase for about 7 years, working with all of our customers, kind of big and small around the world. So today, kind of following on from some of the highlights that Ravi talked about in the keynote, we're going to do kind of an introduction to what we mean by a data platform at Couchbase, and specifically from an operations perspective, what that means, how the system behaves. A lot of it's going to be somewhat high level because we have a lot to get through, and the various tracks throughout the day will go into more depth in some of the concepts. Hopefully we have time at the end for a demo. Depends on how long I take on each slide, and at the end of that, hopefully some time for questions. So with that, one of the things we talk a lot about at Couchbase is the need to combine the requirements and needs of development and operations. It's no use to you if you can easily develop an application but can't run it at scale, and it's not really useful to be able to run something at super high scale if you can't develop with it. And so we talk about those two very much in concert, and the capabilities that Couchbase, the features, the way that we talk about it, support both of those together. Today we're going to be focusing mostly on the right-hand side, the operation at any scale. But first, let me just give an introduction to kind of how we see Couchbase fitting into the data management ecosystem and landscape. So we talk a little bit about multiple layers of data management, and you're being presented today with the choice of lots of different technologies. Many different technologies say they do the same things. With Couchbase, we like to focus very much on the interactive, user-facing applications that have a common set of requirements. They have the need for consistent performance, the ability to have flexible data management, evolution of that data, constant availability through both planned and unplanned maintenance, whether you have to scale out or whether a node fails. The application itself, the requirements that it has, needs to keep running, keep serving users. And so we primarily think of Couchbase fitting in that middle layer, but you'll also see down at the bottom some of the data sources that are feeding your application can also be relying on Couchbase. Taking another slightly different view of this, we talk about the Lambda architecture, things that you guys might be familiar with, talking about the need for both batch management of data and also streaming management of data. And we have data coming in on one side at that ingestion from various sources. Maybe those are part of your application as well, maybe not. Maybe you're getting that data from other services or other even companies that you subscribe to, going through this whole stream, and on the other end, you're presenting the results. Right? You're showing either your application or you're serving to your customers whatever you've done with that data, however you've managed it. And we can start to see where different technologies fit into this, and we'll see Couchbase in a minute. Kafka is a great technology for managing the movement of data from one layer to another, subscribing to topics. Couchbase obviously works hand in hand with Kafka. We typically talk about Hadoop being at the data lake layer, the offline or batch-oriented data management. We talk about Storm and Spark being the main kind of technologies in that streaming, complex event processing. Some of you might be using other technologies. And then we see Couchbase fitting in a couple different layers. Couchbase is very good at taking the data in because of the performance and the availability that it can provide. Its speed and low latency allows it to be a very good intermediary data store if we come down along the streaming platform as you're working with data, as you're processing and computing those aggregations or profile enhancements. The streaming layer needs a persistent store. Couchbase fits very well there. In the middle of that, the incremental location for storing the results of your data as you're working with it, as you're serving it to different services within your company. And then finally on the presentation layer, the final resting place before sending it on to your users or to your customers. So again, just kind of a high-level view, some of the different common trends that where we see Couchbase fitting in. When we talk about the data platform, and this is hopefully a slide you all saw not too long ago, and the keynote, all built together. So Couchbase software providing data management, data storage, querying through Nickel, search through full text indexing, mobile synchronization up and down to a mobile device, analytics coming on for longer running query, ad hoc querying, all built on a memory first, scale out, horizontally scalable architecture with security and integration kind of as built-in part of our mindset of integrating with the rest of the big data ecosystem. And then all sitting on whatever your infrastructure is. Some of that's physical hardware, some of that is virtualized instances, some of that is cloud, public or private cloud, and now a lot of that is in containers, right, with Docker and Mesosphere and OpenShift and Kubernetes and all of the new container technology. Couchbase is very focused on making sure that we are not only available but also functional and performant in whatever, on top of whatever infrastructure you are deploying on top of. Painting just a couple more pictures here before I get into some of the details. The full stack of Couchbase, from the edge on a mobile device or an embedded system, replicating through a layer that is managing that data routing, the synchronization, and then storing all of it in a back-end database, the Couchbase server. We talk a lot about full stack management, where there are different requirements for scale, for security, for flexibility at each of these layers, and we've thought about and have a single system. Whereas before, and even today, you would have to join multiple different technologies together. You would be either writing your own mobile synchronization, you'd have your own separate web layer, your own database layer, you'd be moving data into a search engine, over to a data lake, and all of that complexity makes it hard for you to provide an application, to operate and grow an application. You have different vendors to work with. You have one technology being upgraded that doesn't work with the old version of another one, and so it's a headache for operators to manage. And that's one of the reasons why we think the single Couchbase platform is such a powerful capability. Not that we can do everything, and we don't sit up here and propose that everything should be in Couchbase, but the more and more that you can get from a single, unified, integrated platform, the easier it is for you to focus on your core competencies of the application. I'll spend just a few minutes on kind of a riff on that. Again, the full stack comes into play when we think about the database layer at the bottom. That's Couchbase Server. That is the high performance kind of NoSQL database that you are hopefully reasonably familiar with and learning about more. The middle layer, your middle tier, where you traditionally have your web services and web application layer, the Couchbase Sync Gateway sits there and provides RESTful and stream-based APIs for serving applications, for providing a security layer on top of the core database underneath. And then connected to that is Couchbase Lite. And Couchbase Lite is an embedded database that sits out at the edge, sits on a mobile device, so an iPhone or an Android device, but also any embedded system out in a car or a wind turbine or on an oil rig, anywhere where you want to have your data, have the data of the application pushed out to the edge, either for performance reasons, because having data closer to you is easier and faster to work with, but also especially when those devices or those edge systems may not always have an internet connection, and you want to put data out there so that they can still function offline. Now, all of these three come together when you're using the full stack of Couchbase, but you're not forced to do so. And so we have this view that your application is wherever it sits. Your application has APIs to access the database at the bottom. If you're building your own web application that has all of the business logic built into it, your application can also talk directly to Sync Gateway if you want to provide simpler data service, REST and stream APIs. And your application is what sits out on the edge. Your application is the UI, is the mobile app that you're providing, and being able to access all three of these layers with a relatively unified programming language, paradigm, be able to use JSON all throughout that and not have to worry about the movement of data. We take care of that. That's what Couchbase is good at doing, moving data from the core data center through that middle layer and out to the edge, or stopping at any one of those points wherever your application makes sense. Just a couple more marketing-ish slides to help paint the picture, and we'll get into some of the details. The Couchbase data platform, again, very focused on integration, on making sure that you can get data into and out of Couchbase, whether it's your application running in C and PHP and Java and .NET and Go and all of the programming languages, or whether it's moving data into a Hadoop, Kafka, Spark, Tableau ecosystem, or taking data in from your mainframe or from an Oracle database or from other services of your application. And so that flexibility of data movement is very important. And it's this kind of core database that we're going to focus on today, the Couchbase server running in your data center or in the cloud. It's that scalable, high performance, NoSQL database that really is the kind of the core of operations discussion. A lot of the other stuff is more out at the application layer and is important for developers and important to talk about in the whole context, but we're really going to focus on the operational aspects and architecture of the database in the background. And finally, when we talk about this, you'll see a theme coming over and over again, this idea of services within a database. And I'm going to talk about it later on in a minute. But we have the need to store data. And that's on the far left-hand side, what we call the data service. That's where the documents actually live. The query service is what handles and processes your SQL-like queries. We have a language called Nickel we'll talk about a little bit more. Indexing, the query engine, obviously any query for high performance relies upon an indexing system. Search, again, our full text search engine built in, analytics coming along. What we're trying to talk about here, trying to present here is that databases of old and even some of the newer ones try to cram all of this into a single engine. Try to cram it all into a single node, into a single process. Relational databases talk a lot about the execution thread. And what we realized very quickly on was that the more you try to cram in, the more functionality you cram in, the worse you make everything else. And so we'll talk about this a little more in a minute, but separating those out, identifying the different characteristics, the different requirements of those different workloads, and providing a system that can be kind of tuned and scaled independently depending on what you need, allows us to be much more flexible for either multiple applications within an organization or certainly across different verticals and different organizations. And then all of that underpinned by a single administration interface. Hopefully I'll get a chance to show you in the demo later on, a single cluster manager that's holding all of this together, a single UI, a single REST API, a single administrative management interface, and then on the top a single SDK layer for your developers so that they don't have to access different APIs and worry about which protocol and which port am I talking to on. It's all abstracted away for them with giving the administrators and the operators the ability to control and migrate and scale the layer in between. Okay, so now let's dive into this a little bit more and really focus on what it means and how Couchbase supports your operations. From an architecture perspective, and this may contradict with something I said before, but you'll see how it all relates. Couchbase is a single node type. Every node that you use as part of the system is a single installation. It's a single RPM or deb or exe package. And the services or the workloads that each node is asked to run is configured at runtime. So if we contrast that to some of the other technologies, Hadoop-based technologies, some of the other NoSQL, you have different nodes types to manage. You say, I need to have config nodes, or I need to have head nodes, or name nodes, or my data is stored over here, but it's cached over here. And for an operator, that can get very complex when you start to scale out one layer. You have to remember to scale out the other layer. You have to make sure you have high availability at all of those different layers. When one fails, how does that affect and impact the others? But with Couchbase, because it's all a single installation that's configured at runtime, makes it much easier to know I just need to add more capacity, and then I add that to the workload that needs more resources or more capacity. So again, I mentioned we have the data service and the indexing service, search and query, and then underpinning all of that is the cluster manager. And the cluster manager is sitting out of band, so it is just responsible for keeping the nodes together, process startup, shutdown, statistics management. All of that is managed kind of transparently to you. But the benefit it brings is you have a single interface into the whole cluster, regardless of what application is running or what other services are running. And we'll talk about that in a minute. Because this single node has the power to run everything, but not the necessary requirement, we see a cluster as a logical entity, whether that's spread across a single node on my laptop, running all of the services for easy development and getting started, or whether it's a 30-node cluster up in Amazon. The whole thing is a logical unit, and you don't really care how many nodes there are. The application doesn't care how many nodes there are in each of those services, whether it's in the cloud or on-premise, whether it's on my laptop or on VMs. It's all a single logical unit. And so we can talk about it in the sense of, yes, there are different services that are supporting the different workloads, the different requests, the different types of things that the database is doing. But this picture, if you'll notice on the bottom, says Couchbase Server Cluster, right? But it's a single box. And so that could be a single box on a single node. Could be on my laptop running these services and behaving exactly the same way. It could be, like I said, a 30-node cluster in the cloud, all as a single unit with those services logically running inside. Does that make sense? And so you'll see here the application, for some of its requests, for some of its individual key value lookups, might be going directly to the data service. For some of its nickel querying, when you have a SQL-based query, that's going to go to the query service. The query service might be talking to the index service to support that query, but the application is seeing it as a single API, as a single interface. Once we set up this idea of services, once we identified that there were different things a database is being asked to do, we quickly realized, as I mentioned before, the need to scale those independently. And so in a traditional database architecture, either relational or kind of the NoSQL databases of before, every node was asked to do the same thing. Every node supported a bit of data storage. Every node was asked to do a bit of the indexing. Every node was asked to do a bit of the querying. And what it meant was all of the nodes had to be at least as powerful as the lowest thing that you were doing, lowest common denominator, right? And so if you needed 64 cores for processing a lot of queries, all of your nodes needed to be able to support that, even if they weren't all storing the same amount of data, or your index requirements weren't as high. And so, and this was actually back with our 4.0 release, we introduced the idea of multidimensional scaling, that no longer does every node need to take a partition or a slice of everything the database is doing, but the ability to group those services within a cluster. And so you may have two nodes that are responsible for handling all of the queries, two nodes that are responsible for handling all of the indexes, three or more nodes that are responsible for just storing the data. And now each node can be, if needed, can be specialized and able to perform and support the functions without the conflicting constraints of being asked to do everything else as well. If we contrast that again to Oracle or Mongo or Cassandra or any of them, every node is doing a little bit of the entire workload, and every node needs to be able to handle that. And it means that you are somewhat restricted in your ability to flexibly move from one performance layer or workload layer to another. And it means that your hardware cannot be specialized or moved in and out at will. So you can imagine the query service processing SQL queries or NQL queries can be quite CPU intensive, right? But it doesn't need a lot of RAM and it doesn't need any or much disk. So why would I have to put SSDs in my query engine just because I needed SSDs in my data service? The index service typically needs more of a scale-up architecture, put more data together so I can keep those indexes together. And the data service typically is a very commodity hardware, scale out as many nodes as you can have or is reasonable, but relatively low powered nodes because the workload of reading and writing data is spread across so many. So you start to see the ability to grow or change or scale out each of these services independently. But again, they're all part of the same cluster. They're all part of the same management interface. The application doesn't need to know whether there's 2 or 3 or 10 of each of those services. And that's that abstraction layer that allows for operations to be easier, but also not require the downtime of an application. Let's talk about sharding a relational database, right? You basically shut the application down, move all your data around, and then turn it back up again. And if you did it right, you can last for a little while until you need to do it again. But with Couchbase, we don't ever want to take the database down. We don't ever want to force an application to change the way that it's accessing data or change the way that that the data is distributed. And so again, the ability to abstract those layers, the operations of a database versus the access pattern. So this multidimensional scaling is really a key part of how we talk about Couchbase, how it comes across, and how operators really need to understand it because you're going to be asked to provide different capabilities for different applications. Some applications are going to be very kind of individual read-write heavy, and so you won't need to worry about the query or the index service. Other applications are going to be very query intensive, operating at tens of thousands of SQL requests per second. So you're going to need to scale out that layer a little bit differently. Some applications are going to be heavily indexed. They may have hundreds or multiple hundreds of fields that you want to index, and so you're going to have to manage and operate that index service a little bit differently for each application. Hitting on another couple concepts, cross data center replication. Is a key part, again, of why companies are choosing Couchbase. From an operator's perspective, it's really, really easy. And so I'm not going to spend a lot of time showing you how to manage this because there's not a lot to manage. Once you set up this connection between one cluster and the other, we manage everything for you. You can have multiple different topologies. You can have one cluster replicating out to multiple other clusters. You can have multiple clusters replicating to a single aggregate point. Those streams can be filtered, but the management of it is done once you finish setting it up. Once you click those 2 buttons. Hopefully in the demo I'll get a chance to show that to you. Different than other technologies, Couchbase has individual clusters that replicate to each other. So rather than the Cassandra model of one large cluster spread globally around the world, with Couchbase you set up independent clusters, whether that be one in New York and one in LA, whether that be one in London, one in New York, one in Singapore, one in South Africa, and you connect them together, but they're all independently managed. So as you grow or shrink one cluster, as a node in another cluster fails, as one cluster is being asked to handle more query traffic than individual read-write traffic, each of those clusters can be scaled independently depending on what you're trying to get out of it without an impact or without an effect on the other clusters within that replication fabric. Okay. So I know I'm going through a lot of stuff. We're trying to cover as much as possible in a high level so that you get an idea of what is most interesting for you. There's going to be people on one side of the room that don't have cross data center replication. There's going to be some people on the other side of the room that have very intense querying and indexing needs. And so there are sessions today and education that we can provide that go into those realms in much more depth. The one thing that everybody is doing is storing data. And so the data service within Couchbase is the most important and similar and common across everybody. So I'll take some time going through that in a bit more depth. When we talk about how is data distributed across that data service, and if we look at this cluster at the bottom might be 3 nodes. Those 3 nodes of the data service are operating independently of whatever querying or indexing you have going on around them. Maybe they're replicating to another cluster, but we're focusing just on how that data is distributed. In other technologies, you choose a shard key. Right, that's a very common concept. Either you do that yourself with a relational database, or you choose that with Mongo or Cassandra. With Couchbase, we do away with that, and the application within its library knows how to distribute the data across all of the nodes of the cluster. We use a CRC32 hash, and that means that the data and the workload is very, very evenly spread across however many nodes you have. So as we go from 3 nodes here to 5 nodes in the same cluster, the application is still reading and writing the same data. It's still distributing it into that same logical mapping, but then that mapping has been updated as you add or remove or swap nodes of the cluster, maintaining a very kind of transparent, very strong abstraction between the application's data access and how many nodes or what's going on at the database layer. Within this service, within the data service, is a strong dependency on caching, persistence, and replication. And so when we look at how these nodes might be set up, that one in the middle has an application connected to it. The one to its left on your side is another node in the same cluster, and the one on the right is another node in another cluster. This might be a little small to watch, but we're going to watch where that document goes as your application writes it into the cluster. So first it's going to be put into that caching layer on the first node. It's going to be replicated out to the other nodes, and all of them are going to persist it to disk. I'll do that one more time because it's probably too small to see anyway. Going into the caching layer, replicated out to all of the places where it needs to be replicated, and then persisted in all those locations as well. And all this is done asynchronously. So if your connection across the WAN to a data center halfway around the world is a little bit slower, that doesn't impact your replication within the cluster. If your persistence to disk is a little bit slower, maybe that disk is overloaded or is doing something else, or maybe even has failed, that's not impacting your replication from RAM to RAM or even across to another data center. So all of that disconnection and that asynchronicity is an important part of what we do at Couchbase. Okay. Again, just a kind of a high-level view on how do each of these services handle load balancing, high availability, and disaster recovery. The data service is all load balanced by your application. There's no extra load balancing layer. In fact, the whole Couchbase cluster is load balanced by the application. And the data service has automatic replication built in. You can segregate that by racks or zones within a cluster so that you can prevent the failure of a whole rack from taking out both your active and replica copies of the data. And for DR, it's replicated across to another cluster, most likely in another data center. And all of that is happening automatically. The query service is, again, automatically being round-robined from your application so that you don't need to care or know which node am I directing my request to. And for an administrator, for an operator, if you're removing one node or adding another in, the application immediately takes advantage of that extra capacity or the change in topology. The index service is load balanced by the query service primarily, and can be replicated again within a cluster for rack or zone awareness. And the full text service at the moment does not have the ability to know about those racks or zones, but it will. But it has replication built in. The one thing to keep in mind when we're talking about replication across data centers for disaster recovery, we only replicate the data. We don't replicate indexes, we don't replicate the queries, and that's to give you the ability to have kind of different topologies or different setups in different data centers. We make sure the data gets there, and then the index definitions or the query layout is defined by the requirements of that data center. You might be using one data center just as a backup, and so you don't need to have all of the indexes propagated over there. One data center might be handling more of your business querying, and so you want to index things more heavily, whereas another one is just handling the load of the application. And it's that kind of flexibility that we focus on a lot at Couchbase. Backup and restore is another critical part of operating a Couchbase cluster. We make this very easy to do. We have a couple different tools, depending on what version you're on, that manage the storage of backups and the eventual restore. You can back up from any cluster and restore to any other cluster, whether it was 3 nodes to 5 nodes, whether it was a bucket called foo to a bucket called bar. We just back up the data, and you can control or restore it into any location. Again, similar to the cross data center replication, we back up the index definitions, but not the data. We let those indexes get rebuilt when the data is restored. It makes things faster. It helps not have to manage the consistency between them. So just the data being the core part, the index definitions being what create those, and those are both backed up and restored. We support incremental backups, and this was an addition a few versions ago when we quickly realized that doing a full backup of a 10 terabyte database is going to take a long time no matter how fast your technology is. By the time you're done backing up on one day, so much data has changed that the next day you can't finish a backup, and you get into this endless cycle. And so now we talk about incremental backups, being able to take just the changes every time. So whether you take it on a weekly basis, on a daily basis, or even we're advocating an hourly basis, because so little data has changed over the course of an hour, that you can keep those backups going without having to worry about 10 terabytes every single time. And there's some management about merging backups, merging the incrementals, and restoring to any point along that chain. But the main point of that is the ability to not worry that your backup is not completing. You want your backups to complete. You want them to complete as fast as possible. Finally, but certainly not the least important, is security. In Couchbase land, we separate security into two sides, two concepts: the administration versus the data access. A lot of technologies kind of merge those and blend those together, but we know that developers are accessing and working with data differently than administrators are managing a cluster. And so there's different capabilities on each layer, but some similarities across them. Role-based access control added in 5.0, well, it started in 4.5, adding in 5.0 the ability to be very, very fine-grained about who you give what access to, whether you want someone to be able to just view the statistics of a cluster, whether you want to have someone just able to manage indexes, whether you want developers to just be able to access their part of data within a larger cluster in production so that you don't have to hand over the keys to the castle. All of those are important parts about role-based access. You can get very fine-grained if you wish, but you can also stay pretty high level and give larger swaths of access, especially in testing or UAT environments where you're less concerned about who is accessing what. A lot of that comes along with auditing, being able to look back and track who did what within the cluster. So once we have the ability to say Joe can do something different than Susie, we have to be able to tell you what Joe did and what Susie did, and that's the auditing part of that. Encryption across the board, whether it be your connection to the administrator interface, whether it be an application's connection to the data, whether it be data replicating between clusters, or whether it be data on disk. Everything has a requirement for encryption, and so out of the box, you can configure Couchbase to do that. And then what else did I miss? Oh, and then one of the things we added recently in 4.6 or so was the passwords and our own configuration going through a separate, what we call secret management layer. So it's not something that you have to worry about encrypting yourself. We manage all of our internal tokens and configuration and passwords separately from your user patterns. I'm running a little bit short on time. I think we're going till 45-ish. Okay. So just to wrap up and try to kind of give you guys some getting started guidance, some of the very high-level best practices for production. We generally talk about the minimum hardware requirements being 8 cores and 8 gigs of RAM. There are some topologies or clusters that can be a little bit smaller than that, but there's a lot of things, a lot of parallel processing that's going on, and so from a baseline perspective, that's going to give you the best stability and performance. But it doesn't really matter to us whether it's physical, VMs, cloud, or containers. As long as the resources are provided, Couchbase is going to make the best use of them. I'll also say that Couchbase scales up very, very well. And so if you go to 64 cores and a terabyte of RAM, which we have customers running in production, a single instance of Couchbase is able to push those resources, 10 gigabit networking. And so where other technologies you'd have to run multiple instances of their JVM or multiple instances of the database in order to push that hardware, Couchbase, in the way that it's architected, multi-threaded, being written in C and C++, can scale from the small of 8 cores or even 4 cores all the way up to the 64 and 128 cores and beyond, and every layer in between, depending on what your resource availability and requirements are. 3 nodes minimum. Whether it be all services on all 3 nodes or whether you start to segregate things out, those 3 nodes give you network partition management, replication, the ability to grow or shrink or upgrade without bringing yourself down to a single point of failure. We didn't talk too much about the development side of this, but a bucket within Couchbase is our logical grouping of data. A lot of people, when they first get started, think about a bucket in terms of a table, and so they want to create tens or hundreds of them. Within Couchbase, a bucket is more synonymous to a database, and so you're only going to have 1 to 3 or so of them. Primary indexes. We allow for, if you want, especially in development environments, to be able to do ad hoc queries, but a primary index is the equivalent to a full bucket scan or a full table scan. And so the control for an operator in production to remove that capability, to say, I don't want any query to be unindexed and therefore cannot take longer than it was benchmarked at. I can't have a rogue query put extra load on the cluster that I wasn't prepared for. You can just very simply remove the primary index, and then that prevents that from happening. Well, let's say the sizing. Sizing is another important part of operations, and it can get very, very complicated. Do I need 3 nodes or 4 nodes or 6 nodes, or does this cluster need 10 nodes or 9 nodes? It gets sometimes it gets overwhelming for people, and so we're trying to talk about kind of small, medium, and large. A small cluster is 3 nodes, anywhere up to about 10 million documents, anywhere up to about 1,000 writes per second, anywhere up to about 1,000 queries per second. That should fit on 3 nodes. Again, those 8 cores, 8 gigabytes of RAM minimum. As you start to scale beyond that, or your application is coming and saying, I need to support 100 million documents, I need to support a few thousand writes per second, you want to go beyond 3 nodes. And you probably want to start separating those services. You want to give the query engine its own resources, give the index engine its own resources, give the data service its own resources. And so that's where you get into the realm of 5 to 7 nodes, making sure that those are segregated. Going beyond that, and we certainly have customers into the multiple billions of documents, that's where you get into a much more kind of fine-grained tuning of, well, 20 nodes, but 15 of them are just for storing the data, and I might be changing, growing and shrinking how many nodes are there for querying depending on the growth and shrinkage of the application. And so we generally ask that you come and contact us and let us help you size that, tune it, understand what capabilities you have in different versions. When you get into those requirements of over a few 100 million documents, if your application comes and says your project manager comes and says, I'm going to be doing, I think about 40,000 writes per second. Let us come and help you, but know that you're going to be into a larger cluster size when you get there. I unfortunately didn't have time for a demo, but I'm going to give us a few minutes for questions as I wrap it up. So thank you very much. Yeah. Questions? Great question. So questions to repeat, what language is the server written in? Do we use threads or processes, and is it M-mapped? So it's not M-mapped. Nothing we do is M-mapped. We have caching layers both for storing the data, also on the indexes side, and none of it is M-mapped. So we manage our own memory allocation. It's an important part of making sure we can be smart about doing that. The other first two questions, the language is a little bit varied. So our core data handling, replication, caching layer is written in C and C++, the data service. Our query and index services are currently written in Go. And we chose that language a few years ago just from an ease of implementation and getting kind of off the ground. We're already having discussions about which pieces of that can or should get rewritten into C and C++ for tighter resource control and better performance overall. And then processes and threads kind of differ based on which language we're talking about. So the data service is all thread-based. It's dynamically thread-based, so depending on how many cores you have, it'll determine how many threads it should start up. The index and query service is more process-based, micro-threads because of Go. Does that make sense? Any other questions? Yes, Mac? Yeah, so the question was, does the full text service run with its own service or with one of the others? It's its own service. And so you can have full text distributed on its own set of nodes or, again, co-located on all of the nodes. We give that flexibility. Full text has its own kind of query and index built in, whereas the Nickel language has a separate query engine and a separate index service because the querying, processing a SQL statement, parsing it, planning it, identifying the index, that's more CPU intensive. The full text engine is more of an API access to an index, and so those two are co-located together and don't have, it's really part of the same process. Yes?
You mentioned something about the non-admin accounts access, right? That will be the feature of 5.0.
Correct. So the question was about the role-based access control and the separation from administrators and the data access. In 4.5, we added administrators' roles. And so you have the ability to say, I only want this administrator to be able to do this thing or that thing separate from others. Previously and up to 5.0, the application access was all or nothing. And so you had a single username and a single password to provide read or write access to each bucket. In 5.0 now, you have the ability to say this user has read-only access, this user has read-write access, this user only can access the query engine instead of other operations. That's what's brought into 5.0.
I'm actually facing the problem of giving that kind of access, the query access to the like QA team,
Mm-hmm.
right? So that they will be able to do select whatever, right? If I understand correctly, that's not yet enabled, right?
It's not GA yet, but that's coming in 5, which is in beta now.
What about the tools? There is a query access in the tool, which can be downloaded separately.
Yep.
Will that help in this situation?
It will, but you still need to manage the access to it, right? It doesn't know that it has different access to the cluster. Within 5, it will. Okay. Yes. Sorry. Yeah, go ahead.
So for the data security, you have some kind of fine level of control if you do kind of multi-tenancy support, let's say certain customers amongst a certain data. So I have multiple customers in the same database, so I don't want to put their data from one and they get on this data.
Yeah, so the question around security, whether we have the ability to provide more multi-tenancy and segregating data access to different groups. The short answer is no at the moment. It's another part of what we're working on our roadmap is a better kind of multi-tenancy strategy. But I would say that to expand the conversation, Sync Gateway does provide a lot of that flexibility, and so you're going to have the ability to separate sets of data and access patterns to different clients, but you have to go through that layer, and it's probably going to be a longer conversation than I can get into right now. Yes.
So the domain we work in is payment processing. There's some use cases around transaction processing where eventual consistency is problematic.
Mm-hmm.
These are things that Couchbase has to address that. And if so, what impact does that have on scalability?
Good question. The question was around specifically for payment processing and transaction management, not being able to leverage eventual consistency because of the need for strong consistency and moving money from one place to another. And what does Couchbase kind of have to offer there? It's a long discussion because it impacts how you model your data, how your application accesses the data. I can say at a very, very kind of simple level, a cluster is strongly consistent, and cluster to cluster is eventually consistent. And so for certain types of those actions, you're going to want to restrict that to a single cluster rather than having the same transaction processed on at multiple clusters. But then the answer expands into how are you modeling your data and what operations are you putting into a single document versus multi-document operations. I don't know. Do I have any time? Okay. Who wants to see some of the demo? Okay. If you do, you can stay. If not, I think lunch is now or in the next 10 minutes. Okay. So yeah, feel free to get up and move around. I can talk while you're doing that. So let me sign out of here. So this is the Couchbase UI, and this is our. Oh, sorry. I got to mirror my displays. Thank you for pointing that out.
Can I have a quick question?
Yes, go ahead.
XD, can I use for backup?
Yes.
Let's say I have 20 nodes.
Yeah.
I'm writing to 3 node cluster.
Yeah.
But then back my family cluster because I'm writing from 20 to 20.
Doesn't matter.
Because goes to memory to memory, and my memory is so much is coming in, but so much is given to backup, but it's not.
Yeah, so the question was, can I use cross-data center replication as a backup layer? And the short answer is yes. Both clusters need to be sized in order to handle the load that is going into them, but they don't need to be the same number of nodes. So this is a little small in the resolution. Let me see if I can. That looks even worse. Let's see if this breaks it. That'll be better. Okay, so there's a lot of pieces to demo, but just as an introduction into this is the Couchbase UI. This is our 5.0 product. The UI has been kind of rewritten, but all of the same capabilities are there from your previous version. The dashboard has a kind of a high-level view of what services are running. So we have our data service here that has 3 nodes, our indexing service that has 2, full text 2, and query service has 2. If we go and look at the servers themselves, you get a list of servers and the services that they are running. So we see 2 for full text, 2 for index, 3 for data, and 2 for query. And this is where you can add or remove nodes of the cluster with just a couple clicks. So if I was going to, let me copy this node. So if I wanted to say remove this node, I would click remove, and I would click rebalance. And hopefully the demo gods just allow that to happen. Yeah, you need a minimum of 1 node per service. You need a minimum of 2 or 3 for any sort of high availability or replication. And good, there it worked. And you also want more than 1 so that you can upgrade the versions without ever losing all of that, the functionality of that service. So if you imagine I had 3 nodes of the data service and 2 nodes of query, I can remove one query node, still serve all of my traffic off of one, upgrade it and add it back in, and then do the same to the other. If I only had one node, I'd have to take it away, and that would break the application's ability to use that service. Does that make sense? Sure. Yeah, software or hardware. We do everything online. So when you upgrade from one Couchbase server version to another, you need the ability to remove nodes, upgrade them, bring them back in without disrupting the application. Correct, yeah. So every Couchbase version, even across major versions, has support for mixed version management. So you can run 4.5 and upgrade it to 5.0 one node at a time. You can upgrade from 5.0 to 5.1 eventually, one node at a time. We publish an upgrade matrix of what we've tested and what we kind of officially support. You can also do cross data center upgrades. So you have 2 or more clusters replicating across the data center, upgrade one of those clusters, and then upgrade the other, and they'll operate in a mixed mode for however long that takes, all without your application having to stop. So that's a good segue into cross data center replication. And so I have, let's say I have 6 nodes here, and I have another cluster running here. With only 3 nodes in it. And so I'm going to create an empty bucket. I know I'm going through things that I haven't talked about, but our docs kind of walk you through this. Oops, backup. And so you see this backup here, this bucket here has 0 items in it, and I can replicate into that from one cluster to the other. So again, this cluster has 3 nodes in it, and this cluster has all services running on all 3 nodes. Go back to my original cluster, which is all separated out, and setting up a cross data center replication link is just a matter of doing this. I can encrypt that link or not. There's certificate management back and forth. And what this first does is just associate those 2 clusters together so that one knows about the other. And then when I want to create the replication, I say from this cluster, I'm going to take my travel sample bucket. This is a data set that is provided with the cluster. It has a bunch of documents and indexes for you to get kind of up and running quickly. Choose my backup cluster, put in the name of the bucket. I can optionally filter the replication here. So if I don't do anything, it's going to replicate the entire data set. I can provide a regular expression here that will only replicate a subset of the data set. But once I click save, it's done. And that's really all you have to do to set up cross data center replication from one cluster to another. If we come over to this one again and take a look, this bucket now has about 32,000 items in it. And if I were to add or remove nodes from one cluster or the other, that replication is all maintained. Yeah, so the question again was if I have a 10-node cluster on one end and a 5-node cluster on the other, the software knows is topology aware, we talk about. So the replication stream knows how to replicate from 10 nodes down to 5, or from 5 over to 10, or from 10 to 5 to 3. We have customers that have a central, call it 20-node database, and they replicate a piece of that to a 5-node cluster in Europe, and a 5-node cluster in Asia, and a 5-node cluster in Australia, all from that same data set. And you, the administrator, or especially the application, doesn't need to care or know how many nodes there are at each end. Correct, yeah. And so the question was around the read-write ability of each cluster. All of our clusters are active-active. And there are some cases where you decide not to write to one of them, but that's your application decision. So all the clusters are active. This is what I just showed was a unidirectional replication stream. I'm replicating just from that one cluster to the other. I can go back, I can create a bidirectional stream by doing the same thing back on itself. And I could replicate if I wanted to be able to write to both and have it cross-replicated. That's just another stream that's managed in the same way. It's network speed. The question was, what's the lag time of replication? We do it RAM to RAM, and so it's your network speed. We can replicate in a millisecond if you have a gigabit or higher network between the clusters. But we have lots of customers that have 200, 300 millisecond delay from London to Australia, and so the replication happens at the speed that it can. We don't use any queues. So you never have the chance of one cluster getting backed up and causing stability problems on itself. We do everything by sequence number, and so even if there's a break for days and days and days, when that comes back online, we know how much we need to replicate and just catch it up. Cool. So I appreciate you all sticking with me. I'm happy to stick around and answer some more questions, but I'm sure you're hungry and want to go to lunch. Thank you.